everyone to this ProScale webinar. My name is Geneviève Debeau, and I will be your moderator today. I'm a partner with Uetliberg Partners, which is a small boutique consultancy specializing in sustainability, and we've been supporting the development of ProScale for the past 7 years already. So welcome, please make yourself comfortable. We're going to, in the next 2 hours, we will first explore the raison d'être, the logic and the workings of ProScale, which is an enabling method providing a way to account for toxicity in life cycle assessments. So as you can see from this slide, our first hour will be devoted to an overview of the method, while during the second hour, we will have the opportunity to see how it works in practice via several case studies. And finally, we will also take some time to reflect on the future developments of ProScale, notably in the field of ecotoxicity. Just a little background of who's behind ProScale. The current ProScale consortium members are the following. It was initiated in 2016 by a group of companies that worked together with IVL, that acts as a scientific secretariat for the project and is now hosting it. The consortium has since welcomed a couple of new members, and actually it's still open for participation, as will be explained later on in the meeting. Before opening formally the presentations, I'd like to also acknowledge the following sponsors that made the organization of today's webinar possible. So they are attached to the webinar, not to the ProScale project at large. The Calimero project funded by the European Union, the FORMAS grant from the Swedish Research Council for Sustainable Development, and the Mistra SafeChem project from the Swedish Foundation for Strategic Environmental Research. And as you can see, the views and the opinions expressed during this webinar are those of the authors and do not reflect those of the sponsors. So without further ado, let me just give a few ground rules for this webinar, a few recommendations to make the most of it. If you have questions, please use the Q&A box that is at your disposal, and we will take time after each round of presentations to go through these questions and allocate them to the speakers. I would like also to let you know that a recording of the webinar will be made available on the IVL website after the event. And don't hesitate, of course, to share that link with colleagues afterwards. Okay, so now, without further ado, let's dive into today's topic with Martin Glöckner, who will give us a background briefing on why ProScale is necessary. Martin is the Executive Director, Regulatory Affairs of Deutsche Bauchemie, which is a German trade association representing construction chemicals manufacturers. Martin has been covering regulatory issues in the construction sector since 1995, and he's been involved in the development of ProScale since its beginning. So please go ahead, Martin.
Yeah, thanks a lot, Geneviève. Good morning, everybody. As introduced, I would like to give you a short overview about the regulatory framework before we came into the details of the ProScale method. I would like to highlight some recent developments in European legislation where LCA data for products and for the raw materials could play a major role. From the viewpoint of the construction sector, so far the demand for LCA data for construction products and for the raw materials was mainly market-driven. The market-driven demand was mainly triggered by the application of certification systems for the sustainability of buildings. Of course, if you assess the sustainability of buildings, you need some information about the life cycle assessment data of the construction products are used for this building, and this was the reason for the demand so far. But to our opinion, this will change in the near future. We have several legislative initiatives from the European Commission under the Green Deal, which will make LCA data for products and for their raw materials part of the legal requirements in future. I have listed here on this slide 5 different initiatives from the Commission which are currently on the table and which could be connected with these developments. I will come to each of them more in detail. You can imagine for the construction sector, the construction products regulation is the most important product-related regulation in Europe, and this CPR is currently under revision. It is already quite clear that the future CPR will lead to legal requirements for LCA data for construction products. That means you have to assess, or the manufacturer has to assess and declare the environmental sustainability for the construction products covered by the CPR. There we have the so-called environmental product declarations, the EPDs, which are well established and which contain all the relevant indicators, and this will be the instrument in future. Within the Commission proposal and also the discussion in Parliament and in the Council, also the LCA indicators, human toxicity and ecotoxicity, are specifically mentioned and are under discussion. That means also these 2 indicators will be part of the legal requirements under the future CPR. Outside of the field of construction products, the ESPR, the eco-design requirement for sustainable product regulation, is on the table of the European legislators and is under discussion in the Parliament and in the Council. For products outside of the construction sector, the ESPR will lead to legal requirements on environmental footprint, on environmental impact data, on LCA data. That means these 2 regulations goes in a similar direction. The CPR will cover the construction products and the ESPR will cover the rest of the products. It need to be established via delegated act. That means for all product groups, product families, which will have or which will be part of delegated acts under the ESPR, they have to deal with these kind of requirements in future. The next one is a big one, the revision of the REACH regulation. You know, there are a lot of very different topics are under discussion with regard to the REACH revision. We will expect that for end of the year. One part of the discussion is around LCA data for substances. The Commission has realized that they have established several new legislative initiatives with regard to products and with LCA data for products, and therefore they think that it is needed to also provide the relevant data for the raw materials, for the substances which are part of these products. And therefore they are considering 2 different approaches. One would be to establish mandatory requirements with regard to LCA data, environmental footprint data for substances in the REACH registration process. This is one option. If these kind of requirements do not fit into the REACH regulation, then a possible alternative could be a new piece of European legislation to make life cycle assessment data for substances available. So this is also in development upstream from the end product manufacturers. The REACH vision is a result of the chemical strategy on sustainability. Another part of these initiative of the chemical strategy is the so-called safe and sustainable by design concept, the SSBD. The SSBD concept in the core of the idea brings together the chemical risk assessment known from REACH with the life cycle assessment. So it's a combination of a chemical life cycle, of a chemical risk assessment and a life cycle assessment for these chemicals. During the pilot projects which have been performed already and which are under development, also the ProScale method has been applied by one or the other participants, and the indicators toxicity and ecotoxicity are specifically mentioned in the SSBD background paper that these need to be considered. So also there appropriate methods are required. The last initiative I would like to mention here is a quite new one. It's the Green Claims Directive, which have been presented by the Commission end of March this year. The Green Claims Directive is covering B2C communication and is covering voluntary green claims from manufacturers which are not covered by any kind of European legislation. So that means for all the voluntary green claims for B2C, a supplier must carry out an assessment to substantiate these green claims based on recognized scientific evidence. So this is one of the obligations under this new directive, and also the supplier need to demonstrate that their claims connected to environmental impacts are significant from the life cycle perspective, and you can imagine that also their methods similar to or like ProScale could be applied in the future. That means all in all, it is quite clear that an appropriate method for assessing human toxicity and ecotoxicity from a life cycle perspective is needed to deal with all these new future legal requirements I have mentioned before. The alternative approaches which are already available does not always provide comprehensible results, and they are not always useful to apply. This is at least the experience we've made in our sector, and therefore we are convinced that the ProScale method could be a useful complement to the existing approaches, and ProScale should be further validated. And this is the reason why we as construction chemical sector have already supported the development of ProScale for the human toxicity part, and we will also support the future development of ProScale E, which will cover then the environmental part. And I would be pleased, and of course the project is open for other interested parties, and I would be pleased if others would join our joint initiative. Yeah, with this I would end my short presentation on the legal framework, and of course I'm available for possible questions. Thank you.
Thank you very much, Martin, for this overview of the context in which ProScale is being nurtured and developed. I will now give the floor to Peter Zaning, Dr. Peter Zaning, who will give us an overview of the ProScale methods. Peter is the Director of Sustainability Methods at BASF. He's a senior scientist that was involved in the process of an implementation of more than 60 LCA and eco-efficiency studies. So this is definitely a specialist in the area. What's interesting is that for a number of years, Peter has also been involved at a very senior level in industry work on LCAs, notably in Plastics Europe, but also in standardization, both at the ISO and the German levels. And finally, Peter is also a professor of sustainability management at the Technical University in Dresden. So Peter, thanks for sharing your views on what is ProScale.
Yeah, thank you very much, Genevieve, for this kind introduction. So I would like to give you an overview on what is ProScale more from a methodological point of view. So I underlined it is an easy to use and meaningful approach for LCA applications. How does it look like? So ProScale is an approach for LCA that helps to ensure the taking into account of chemical risk-based elements in the lifecycle assessment. So I think that's a new approach. It's closely linked to the risk assessment that you know from assessment of chemicals, which is done for a longer time now. And we wanted to use the accepted methodological approaches of a lot of experts in Europe, but also all over the world. We want to prevent the use of hazard-only assessment methods in LCA, because we think that is a misleading approach and gives you wrong indications. And we wanted also in the development to create a meaningful human toxicity result for LCA, because now we're talking about LCA, not really specifically on risk assessment. So that must be always clear. We have it explained, and we put it also in the context of LCA. ProScale approach uses on one hand existing data, so you don't need to create new data. All the data that you need are available. Sometimes you need to search on one or another level, but we use on one example reach-based information. So many experts created these officially accepted data, and we are able to integrate them easily to our approach. We use technical information from processes in engineering, and we use risk and direct exposure assessment for workers and users based on EU methodology, for instance, ACTOC-TRA and others. So at least we did not reinvent the wheel. We used really what is existing, what is used, and we transferred it to the LCA approach, make it applicable, and make it accessible. Furthermore, we implemented a complementary approach to other approaches, so that's LCA compatible, so it needs to be integrated in the LCA result. We created also normalization factors so that you can combine it with other environmental impacts, and you can create at least an overall LCA study result assessing here human toxicity. Martin also mentioned the development of ecotoxicity effects that we're still working on. It's ProScale E, which comes next. The scope of ProScale covers the direct human toxicity for different stakeholders, focusing for sure on workers, but also focusing on service life, focusing also on end of life. So it's a life cycle based approach. So we really start from the cradle and end at the grave. So that is a LCA compliant approach following ISO 14040, ISO 14044 for sure. And here you see it's displayed really from raw materials, from production via professional use, consumer use, service life, and end of life. So we can cover all these topics, and that is in the scope of ProScale. What is outside of the ProScale is the humans via the environment, ecotox via the environment, where from our perspective, HughesTox is focusing on. And so that's, I think, a clear distinction. And we think for the direct tox, where for sure Green Deal, but also other initiatives in Europe focusing on, also the green claims focusing on. So do we harm someone directly? Is someone getting in trouble if using these materials along the whole life cycle? So that's a unique approach of ProScale, using easy available data, but also focusing on these aspects. ProScale works in general with four main pillars, and it out of these assessment of these four pillars, a ProScale result is aggregated and derived from. So we, for sure, we consider the hazard of materials with the hazard factor. So that's a substance hazard based on H phrases and based on the information you can get out of REACH or safety data sheets or different other sources. So we published also a methodological paper which in all details describes how to do that. Then we combine that with an exposure concentration factor coming from ACTOC-TRA. So that is the risk assessment approach where we say hazard times exposure against then the theoretical risk. We combine it with a person-hours factor, which means how many persons are in contact over what time with these materials. And that is also relevant to consider meaningful steps and also to overcome sometimes the problem of LCA defining life cycle steps, because if it's just a short one, it doesn't make a big difference. And so it's not so important how many steps you really define. That does not influence the result at the end. I know that is one of the aspects you need to consider, but here again, it's closely linked to an LCA, to the goals and scope, and also to the system boundary approach you derive and define in an LCA. And last not least, for sure, mass flow needs to be implemented there, how much material we're talking about, and that overall gives you this ProScale figure. And just to give you an overview, for sure, there are much more details behind it, but that is good for now. How can ProScale use and support, can be used, and how can it support decision making with LCA? You know, we have now the PEF methodology, the PEF approach there. So you have a bunch of environmental impacts, mainly 16 indicators, impacts that should be considered. Human toxicity is one of them. And there we think ProScale fits quite well and quite nicely. And this approach will help also to empower lifecycle assessment on human tox and later on also on ecotox aspects. And the way to do that is the same for all other indicators. So we have a characterization model. We have the lifecycle inventories. We have this characterization model, and then we can aggregate the results further. I showed you an example of what we're using here at BASF. It's a spider diagram, but you can different types of graphs, which is an internal normalization if you compare two or more different alternatives for a so-called functional unit. And then probably together with a normalization scheme of PEF and probably also with a weighting scheme of PEF, you can create a single score out of this, and you can clearly compare which alternative is a more sustainable one, which is a more preferable one. And you can also identify what the contribution here is of human toxicity among the others, also to avoid trade-offs, also to avoid misleading information. I think this is the approach that really makes it clear and transparently and leads to a final result in decision-making. ProScale and ProScale E later on results can be used in different programs. So Martin highlighted some of them, so I just summarized it here. So product environmental footprint for sure as an LCA method, ProScale can contribute there, but as well also for sustainable product initiative, SSBD, but also REACH, EPDs and so on. So this general holistic approach that considers the whole life cycle of materials and products can be used in different ways with meaningful results. So with that, again, you already know this slide, so I will not repeat that, but I would like to thank you for your kind attention, for your interest in ProScale, and looking forward to your question. Thank you very much.
Thank you very much, Peter. We will now dive a little bit deeper into the workings of ProScale with Thomas Rydberg. Dr. Thomas Rydberg is a senior researcher at IVL, the Swedish Environmental Research Institute. And Thomas is active in the areas of sustainable production, energy and resource efficiency, and CA, of course, and environmental management. And Thomas, we're lucky he's one of the pioneering researchers in Sweden in these areas and has had over 30 peer-reviewed publications. Thomas currently serves as the technical secretary of the ProScale consortium, in addition to being activity leader for SSBD case studies in the PARC project from the EU. And he's also a senior advisor in the Swedish MISTRA SafeChem research program. So Thomas is pretty well qualified to give us a deep dive into the method itself. Just a small reminder, don't hesitate to put your question in the Q&A box, as we will take some time after Thomas' section Thomas' presentation to go through these questions and answer them. Thank you very much. Up to you, Thomas.
Thank you. Let me know if you see the screen all right with my presentation.
Yes, we do. Thank you.
Okay, perfect. So I'll just go ahead. Okay, so I will give a bit more depth to the method description that you already heard on an overarching level from Peter Zahling here. And first I'd like to mention, or maybe we can start at this end to let you all know that we have a ProScale guidance document that's outlining all these details, in fact, that I will tell you now. More or less, at least, and it's I will also give a better instruction how to find it later on, so you don't have to remember this full link if you are not able to remember that already. So you have seen already the 4 elements that are the fundamentals of ProScale, but what I will do now is I will look more into what we have defined as the default settings for all of these, well, for the 4 categories basically, or 4 factors. And I'm using the word default settings because, and I will tell you in a short while why, but the H phrase or the hazard factor, sorry, is based on H phrases or reach combined with an OEL or DNL modification to reach a numerical score. We have an exposure concentration built on the EasyTOC-TRA, as you already heard. We introduce a person-hour factor that has the meaning of essentially translating the exposure into a dose for the concerned cohort of people. And we also combine it with a mass flow in order to, let's say, put it into the life cycle assessment context with the mass balances that are at stake in any life cycle of a product, or for that matter, another technical system. So I refer to this as default settings because if you, for example, have done measurements on the exposure in a specific site, you might as well include that in the exposure concentration factor rather than the default number from EasyTOC-TRA. Or if you know the number of people that are working on a plant and you know the production volume there, which you typically do if you are the operator of the plant, you can use that instead of the defaults from the BREF. And if you have the detailed bill of material from your own production or operation, or from a supplier for that matter, you might as well use that and not necessarily database data on the mass balance for a specific process. However, in the data repository that we have in ProScale currently, that I will talk a little bit about later on as well, we have a number of data sets, and they are predominantly, or I would say almost to 100% developed based on these default settings, just so you have this, this is clear. The hazard factor, if we look at that, comes from the idea that we thought that it might be quite useful and also possible to organize the different hazard classes for human toxicity into different hazard classes, and we assign then a numerical score to each hazard class according to this table. So each inhalation, oral and dermal route for exposure are, let's say, dealt with through their own H phrases in many cases, but then there are also some H phrases that are common to all exposure routes, so this can also be identified in this table. Then many substances will have several H phrases assigned to them, and in that case the H phrase that belongs to the highest hazard class according to this table will determine the numerical score for the substance. Also, as an adaptation to the EU specific system beyond the global harmonized system, we've added the EU H specific H phrases for EU only. And then, of course, this table will need to be, let's say, looked into and fine-tuned maybe from time to time. So at some point we need to introduce, or we are, let's say, discussing to have different versions depending on the timing. Not so much, well, I mean, it happens that there are new hazard classes that are introduced, but also, of course, specific substances will from time to time change the classification because of new findings. So the hazard score of a substance is not necessarily a once and for all fixed number, but of course it has to be fixed within a specific version of the hazard scoring. So if you have a substance that has as one of the classifications, the H350 classification, it means that it will be scored within the band between 10,000 and 100,000, even though it may have many different hazard classifications also, but then belonging to lower hazard classes. And I will tell you an example in short, but I will go through the different factors here a little bit first. So you recognize the H factor bands here, going from 1 to 100,000 basically, and then on the x-axis we have listed the OEL in this case. So if you have accepted OELs for various substances, you can fine-tune the score for the hazard factor a little bit through this table, and of course it's made in a mathematical way with the underlying algorithms and not through the graphical way, obviously, but it's a good way of illustrating how it works. And basically it means that if you have a substance that has a very low OEL, meaning that a very low exposure and dose will lead to an effect, then the hazard factor is at the higher end of the spectrum or the class. The border or the boundary for getting to the top number of the class is 0.1 milligrams per cubic meter, as you see here, for inhalative exposure. And at the other end, you have a declining, declining hazard factor depending on the OEL, going down to around 300 milligrams per cubic meter. And if you have a higher OEL than that, you still will, let's say, the substance will still be assigned the hazard factor of this class, but then at the lower end of the hazard class. Then there are some specific cases. If your substance has, let's say, it doesn't have an H phrase. This, of course, is an issue because it can sometimes mean that it has not been tested for classification or doesn't have to have a classification because it's produced at small amounts. I will talk about that in the next slide. But if you have such a substance, but it has somewhere an OEL or a DNL, you will assign it to hazard class A in the current thinking we have. If you have, on the other hand, sometimes a substance that's in fact classified, meaning that it has been tested and it has been deemed not hazardous, then of course, and it doesn't even have an OEL or DNL factor, then it remains that the hazard factor will be 0 because obviously it has been classified not to be hazardous in this case. It's fairly rare that this happens. So, but then going into the issue of what happens if we have a substance that has no classification yet. So there is a data gap basically, and we don't have even an OEL or a DNL. And of course, this will happen to many new developed substances that are not produced in significant amounts. So this is a very relevant aspect if you look into the safe and sustainable by design context, where the aim is specifically to look into new developments and innovation projects. We've said there that if you're coming across such a substance in your system, the first option you may apply is to assume the highest possible ProScale score as the first iteration. And if you are familiar with life cycle assessment, you know that there is a lot of data needed for different types of the analysis, and it's easy to get stuck. So we just said that in order not to get stuck, just assign this highest value, and then you can carry out your analysis and then go back when you find out which hotspots you need to look further into. And then there are various, well, we have an approach underway that's basically looking into consecutively operational or running through computational models for the hierarchy here. And then it's quite convenient that the model can, let's say, stop at the hazard class that assigns to the substance the highest hazard class, because if you run if you run computational models for CMR substances and you get a flag there that it should be classified there, then you don't need to go any further, because then you know it will belong to class E anyway. But if you pass, let's say, a class E test, you can go further down. And of course, this is a bit complicated, and computational models are not necessarily directly applicable for regulatory purposes, but as a method to derive an indicative hazard indicator, it should work well. Yeah, on to the exposure concentration factor. We've already talked about that a little bit, but a very key concept in the EasyTalk-TRA model, and in fact also in the KESAR model, which is recommended by ECHA and provided by ECHA, is the process category, or PROC for short, which means that various chemical production processes or processes containing chemicals and potentially causing exposure have been sorted into roughly 30 standardized process category descriptions, and they can be found in this guidance document from ECHA. And there is a descriptor list of these process categories there, so you can get familiar with how all these PROCs are defined essentially. Of course, it doesn't necessarily cover everything you come across in a production system, but so far we've at least seen that it will, to a very large extent, be possible to assign a specific, let's say, real process to something that sounds similar to what is defined in the PROC. So that's very useful. But this is also one of the developments we are looking at, how to be able to define that even further. And of course, PROCs are then applicable to production processes, but also to end-of-life process if they are done in an industrial setting. So the only, let's say, part of a product system that cannot be covered by the PROC is the use phase, or the service life, if you prefer that word. So just a few brief examples on what these PROCs or how they are defined for those of you who are not so familiar with this concept. PROC 1 is, you could say, corresponding to quite many large-scale and well-sealed chemical industry processes. And then you have some other processes that are relating to the chemical industry with, let's say, increasing risk of exposure until PROC 4. And then you have others for mixing, you have for transportation or transfer of substance, you have for, let's say, further processing of polymers or tableting and so on, and also some other processes that are possibly more related to other industry sectors than specifically the chemical industry, like here, the metal industry and the engineering industry. The PROC is a core concept in the EasyTalk-TRA approach for estimating emissions. The let's say specific version that we're relying on currently in ProScale is the EasyTalk-TRA version 3, and specifically the technical report 114 is the key report there. In that report, there is an appendix where you can find, in fact, the numbers that then, let's say, are the result of going through the models. And these numbers are small, and I won't expect you to read it, but this is how it works. The exposure in the model depends on, of course, some exposure determinants leading up to an exposure prediction. And the parameters are the PROC, but then also the use setting, if it's industrial, professional, or consumer, the type of substance you are dealing with, solid or volatile, if you're applying risk management measures or not, and the characteristic of the substances, the likelihood of becoming airborne for the inhalation exposure, obviously. Dermal exposure is relatively similar, but it doesn't contain the fugacity part specifically. Just a brief example of what happens with different procs for certain substances and not certain fugacity levels, because the fugacity levels are also organized in various classes, depending on the vapor pressure if you're talking about volatiles. So it leads to an exposure concentration estimate ranging from, you could say, 0.01 up to 250, as according to this table. And this is for the setting without any protective measures. The protective measures can reduce the exposure one additional or two additional orders of magnitude. So that will be shown in the next slide, because what we also did, and now I'm a bit quicker and I hope you follow briefly anyway. We have also introduced a kind of a transformation factor or mechanism for the exposure concentration. So the exposure factor that we are in fact working with in the method will not have let's say a value higher than 1, or you can see on the x-axis the estimated exposure coming out of the EasyTalk TRR here, and on the left graph it's for the inhalative exposure. So the total range there is from 0.0001 up to 1000, and that's like the maximum range of numbers that comes out of the EasyTalk TRR model. But we were discussing that because the hazard scoring spans over 5 orders of magnitude, we also wanted the exposure factor to span over 5 orders of magnitude. So that's the basis for the conversion of the factor according to this algorithm. And that's all I will say about that for now, in order to save time. But if you have questions, I would be happy to explain further. The person-hour factor is, as we mentioned, a mechanism or a factor in place in order to translate the exposure concentration, which is essentially a concentration, obviously, to a number that's rather representing a dose in relation to a unit of produced product. And this is what we need in order to apply the method in a life cycle assessment context, because there you know we work with a functional unit, so we want to relate the various impacts to a specific, you could say a mass flow, or a mass flow but translated into a functional unit. The person-hour factor comes with different algorithms also depending on, let's say, the type of process. But if you look at the first line here of the equation, it's typically based on the annual hours worked divided by the annual production volume. And then if you have some installation or service operations, you may need a bit different inputs to the calculation, but essentially it's giving you the same type of output. We have defined a list or established a list of default person-hour factors that you can use if you have nothing, if you don't have the specific information available. And there we based it on reference data coming from best available technology reference documents. It probably gives a bit of an overestimate of the people working in a specific, well, in the plants, because it also includes, of course, overhead staff, if you call it that, in marketing and so on in a specific sector, but rather an overestimate than an underestimate is also kind of a philosophy that we have used when taking an approach to these default factors. And this has led to, among others, these examples of person-hour factors. And you can see that quite many of them are in the order of 10 up to the power of -3 hours worked per kilogram of produce, or you could say that it's about 1 hour worked per ton of substance or chemical. And then for some, let's say, specialized chemical production, you have more people working per kilogram of produced product. So again, this can be used if you have no better specific information to rely on. And it's not, of course, exhaustive, but person-hour factor is relatively easy to come up with some own estimate if you know where to find it, for example, in the BFRF documents. And if you look at the thing like oil extraction, and you have 4 times 10 up to the power of -4. And this is relevant because we looked before at the H phrase for oil, crude oil, or let's say I pointed to H350, which is valid for crude oil because it's classified there. And I will come back to that in the example that I will show you very briefly at the end of my presentation. The mass flow is related to the fact that in a product system you have various compounds being mixed into the final product at some point and in several steps quite often. So the meaning of the mass flow here is essentially that if you look, for example, at this product X production, you have input of, let's say, 0.7 kilogram of ingredient A and 0.3 of ingredient B, which means that if you have assessed the ingredient A production for 1 kilo of output of the ingredient A, you should only account for 0.7 of that score when you calculate the ProScale score for product X ultimately. And similarly then for ingredient B, that you should account for 0.3 kilogram of that ingredient. For those of you who are familiar with LCA, this is common practice, of course, so nothing very specific there maybe. Very briefly then, the example, how this is done in a step-by-step manner. If we look at the crude oil extraction, and now it's very simplified, we just assume that we have an extraction, it comes and the crude oil is coming out. For the illustration purposes here, we say that it's a PROC 2, so there is some but relatively small risk of exposure in this case. The substance is crude oil, so what is the H phrase? It's 350, so it belongs to H ProScale class E, the highest class as we saw before. Maybe there is an OEL, but I choose to here for the illustration purpose say that I didn't find one. So then the ProScale hazard factor will be 100,000. Next, the exposure concentration factor. Well, we know it's PROC 2, but we also need to know what the vapor pressure of crude oil is. So I found some value there, and frankly speaking, it's not always once for all and established. You can find in literature often several values for vapor pressure. Here it doesn't really matter because it's far beyond the boundary condition for the class high, so it belongs to high. For the estimate here, I also said we don't have risk management measures. Of course, this may not be true for a specific case, but for illustration here. So what happens there when we look at the exposure? Well, EasyToc-TRA will provide the value of 25 milligrams per cubic meter, and then with this transformation algorithm that I showed you, we'll have the exposure concentration factor of 0.07 coming out for the further calculation. The person hour factor, according to the previous slide, was 0.0004. The mass flow here, because it's for the unit process, we have 1 kilogram crude oil coming out, and then we can multiply them all together to form a ProScale score for the unit process for crude oil extraction, and that will be then 100,000 times 0.07 times 0.0004 times 1, and then we end up with 2.8 ProScale points for inhalative exposure per kilogram of crude oil produced. Thank you very much for listening, and I hope there are some questions and answers. Over to you, Genevieve.
Thank you, Thomas, and may I invite Thomas, Peter, and Martin to put their cameras on. We indeed have a few questions on this first part. One has already been addressed by Thomas in his presentation, the fact that if there are no known hazards for a substance, would it still be of value to evaluate it with ProScale? Many substances have data gaps. Do you want to comment a little bit on that, Thomas?
Yes. Well, ultimately, if you don't know if there is a hazard or not, it's a it's a problem. But it's the same with any method that tries to assess chemicals, I guess. So and that's why we are also underway with the approach to suggest various computational tools to provide at least a preliminary assessment. And if you want to be on the very safe side, you can always, like I mentioned, start with setting the hazard factor 100,000, because if the other factors in the assessment, so the exposure or the mass flow, are low enough, you will anyway not have a significant input from this particular chemical. So rather than just getting stuck, I think it would be better to start by setting the highest possible hazard factor and then continue with the assessment until you have seen what comes out.
Okay, thank you, Thomas. Another question is about functional units. Can you elaborate about functional units, and can you describe how to decide most appropriate functional units and give some examples? I guess part of that will be addressed via the examples part of this webinar, but maybe some generic approaches.
Yes, if I can say something, and Peter and Martin may of course fill in there, but if you remember the example with the mass flow combining 0.7 kilos of one product and 0.3 of another one, they of course, if we disregard for now any particular or potential losses, they will of course contribute to 1 kilogram of a mixture there. But then of course, let's assume that this was a paint product and we apply the paint to a surface or a wall of some kind. It's not always relevant to talk about 1 kilogram of paint. It's more relevant to talk about a certain surface area that we want to cover with the paint, because at some point you may want to, for internal purposes, look at the various performance differences in from different paints. So it may be, in fact, that a certain amount of paint is needed to cover a certain surface area with one paint, and with the same amount of paint for the other product, you may, cover a very different area. That's part one, and then ultimately they may also, let's say, have different durations. So maybe one of the products may last for 10 years before you have to repaint, whereas the other one will only last for 5 years. So if you talk about paint, the functional unit is typically an amount of time during which you can keep a certain surface area covered by paint with significant, or with the appropriate performance in terms of, let's say, what do you call it? Visual appearance, but also maybe corrosion resistance, for example. Okay. So therefore, the functional unit may be different. Well, you define the functional unit as the basis for comparison, and that may lead to different mass flows if you compare different products that you want to apply to produce the same type of, the same function.
Thank you, Peter. Thank you, Thomas. Sorry. There are a couple of questions relating to ProScale versus other methods. There's one which addresses specifically what's the difference between ProScale and other already designed ecotox LCA models like LC Impact, Impact World Plus Recipe 2016, USTOX. I guess we won't go into the details, but if one of you could provide an overview on that. And then a secondary aspect to that is that the fact that USTOX also covers indoor exposure. Would you recommend to use ProScale instead of USTOX for occupational toxicity impacts, or are they complementary? What is the unit of ProScale CFs? who would like to take that
probably
question?
if I start, and Thomas might add there. So what ProScale is doing, so we focus on direct toxicity as you do it in a risk assessment. So what is a contact a person can get with a chemical, and we address it. And also indoor emissions can be considered there. There are models behind that how to do that. Depends always which case you consider. The other models, or most of them that you just highlighted there, they deal mainly with physical physchem data, physical chemical data, and use that as a basis for their assessment, plus some toxicity hazard factors. And they also consider mainly fate directions. They have a long-term scope. So, for instance, USTOX uses a very long-term scope and considers also fate over the environment, which we don't do. And therefore, you create really different results if you use one method versus the other. And that's also why we think it can be a complementary approach. But if you really want to see what is a direct tox, and that is the main idea of SSBD, they don't have indirect tox, they don't have fading in there. If you have design for environment, if you have sustainable design of materials, then you always talk about direct human tox and ecotox, and therefore ProScale, from our perspective, is the most appropriate approach there. But probably you might add that, Thomas or Martin.
Well, I feel a bit uncomfortable about talking about other methods in a way, but of course, so I agree in the, let's say, overarching picture that you give, but of course we have a reason that we want to promote ProScale, and that's because one thing is we think that it's, or the ambition is to have a method that's lean in data need, you could say. So it will also be possible for the practitioner to come up with something that works and give you a good indicator of what is good or what is bad and not what is not so bad maybe. And that's a specific reason, I think, to rely on the hazard classification in this way, because then if you have substances that are in fact classified, you can easily find or derive a score that makes sense in your assessment. And then, of course, we also appreciate and realize that there is an issue with substances that are not yet classified, and that's why we're working specifically on this. But I think, yeah. I guess this is the main thing, and I don't know all the other methods in that much detail, but in principle, most of them are trying to be rather rigorous in terms of their scientific accuracy, and therefore they require much more or are more data intensive. So I think this is essentially that, and especially that is applicable when you come across substances for which you don't have characterization factors.
Thank you, Thomas. Quickly, a couple of other questions, but some of them will be addressed actually in the second part of the meeting. But and I think, is there a physical meaning to the ProScale unit score? Sorry. Also, can this score be converted into other impacts such as DALY, for example? Briefly.
The simple answer would be no, but it's a boring answer. So, but to be frank, as we have this transformation of the exposure concentration via this algorithm where we, let's say, compress the range of exposure factors from, like I saw my graphs there with the line for the exposure concentration, it kind of takes away the physical meaning of the exposure concentration, and also a little bit in the same way the hazard factor, in the way that it classifies different hazard classes into these different bands within each one order of magnitude, it also kind of takes away the strict physical meaning of the toxicity assessment. So you might say that there is a certain element of what we sometimes, you could say value-laden valuation or weighting involved in the derivation of the hazard factor, but the key point here is that it relies on a value that has been, let's say, politically agreed more or less when the hazard classification was agreed among those who are involved in that process. It's a long answer, maybe to a short question, but a little bit better than to say no. However, you could actually approach it from, let's say, the other end of the spectrum, and if you at some point have, and I know other people are working on that, we are not, let's say, directly working on that in our group here. If you could identify, let's say, DALIs on the global scale coming from chemical exposure, we could translate that into the let's say ProScale score for global chemical exposure related impacts, and then we could create a conversion factor between a DALI or a YOL or some of these concepts into a ProScale. So you could say that a certain number of ProScale points will translate into one DALI, for example. So that's one thing. I would like to add one additional small comment there, and it's the fact that we are looking in parallel on the inhalative exposure and the dermal exposure, and of course there is also the oral exposure, but that's very rarely relevant in a production system context. It is, however, sometimes relevant in the use phase. Anyway, there is, let's say, added complexity involved here, because the internal exposure is not, let's say, constant. So you cannot automatically say that a certain exposure by inhalative exposure corresponds to the same or another exposure level on dermal exposure in terms of what effect it causes. So that's an issue we have dealt with so far by saying that we deal with the different exposure routes independently.
Okay, thank you, Thomas. There's one last question that we can probably address in the course of the next session about the consolidation of different material-related HF and ECF factors. But okay, so that marks the end of the first part of our webinar. Thank you, Martin, Thomas, and Peter. You will stay available, of course, for further questions. Now we start the second part, which is more practical and orientated on case studies, and I welcome Adrian Bird from Clariant, who will get us an overview of a flame retardance case study. Adrian is the flame retardance advocacy manager at Clariant. And he's very much involved in sustainability and advocacy issues in the segment electromobility and electronics in the additives and absorbent business unit of Clariant. And he's also chairing the Association for Non-Halogenated Phosphorus, Inorganic and Nitrogen Flame Retardants, which is a sector group of CEFIC. Adrian, we're all eager to hear from you how you applied ProScale to phosphonate flame retardants.
Thanks very much, Genevieve, for this kind introduction. Happy to be here. So let me tell you a little bit about our case study, which we performed on our Clariant phosphonate flame retardants. So let's jump in and briefly explain what are we talking about. So the class of phosphonate flame retardants which we produce here just south of Cologne in West Germany are diethyl phosphonate salts. The aluminium species, mainly zinc is also available as a commercial product, but it's mainly the aluminium salt of this diethyl phosphonic acid that is used in polyamides and polyesters, also in other smaller applications, thermoplastic elastomers, epoxies, adhesives, and so on. And these go into electric and electronic applications. And the use case we have been looking here at is a USB connector. It could also be a DDR socket in a computer. So that's the final use case in this case study. And these products are white powders, filler-like flame retardants, and typically dosed at something like 20% in these polymers, just to give you a rough idea. And looking at key results, I only have this slide. So we used ProScale to look at the production process of this specific formulation, Exolid OP 1400, which consists of the phosphonate. Our internal name is DEPAL for that, for the aluminium salt, and a synergist. And they go through 3 pre-processes or raw material production stages. The DEPAL starts at white phosphorus or P4, and the synergist is also phosphorus based and has these different intermediates. And what we found here as the ProScale points of these different processes, and here is only shown the DEPAL process, is that P4, white phosphorus, really dominates the toxicity points, and it's inhalative exposure that is dominant. The intermediate A and B to some degree, DEPAL and that does not show here. It's almost zero. Also, dermal exposure or dermal toxicity is next to zero. You only see a small blip here in intermediate B, and oral is zero across the board. And that's not really a big surprise, because chemists know that white or yellow phosphorus is a very hazardous toxic material, toxic to humans, also to very toxic to fish in the environment. So that's not a big surprise. What I found using the ProScale methodology is that there is a big impact of which protective measures you choose in the different steps. For instance, when I did start in the first draft, and in one of these intermediates, there's sulfuric acid involved, and if you don't select any protective measures, the sulfuric acid will even surpass the P4. Yeah, but that's also, I think, reasonable or can be explained, because yes, protective measures for very reactive chemicals do have a big impact, and you need reactive starting products. For most chemistries, you need something that's very reactive to then form something that in the end, like this DEPAL, is really non-hazardous, has a very, very low toxicity potential. But to form something, you need reactive starting products, and reactivity generally also means reactive towards organisms, tissues, biota, so toxicity. Yeah. Which can then be controlled or abated by relevant or applicable protective measures. So our takeaways were, yes, ProScale is straightforward to use. We tried both the web version and the there's also an offline Excel-based version. The web version is easier to handle and simpler to use. As with all tools, input data quality is really essential, and to get the necessary input data from downstream materials. And although it's a simple tool, as with this example of sulfuric acid and white phosphorus, yes, there's still a number of parameters that need to be adjusted, and that you can model, and where also the information may be lacking. Yeah, I don't know exactly how our supplier downstream, how exactly they produce, and we have several, how they produce the white phosphorus, what exact protective measures they have for their staff. So there's also some estimate necessary. And also not a big surprise, ProScale in our case confirmed the hotspots from MSDS data, yes, yeah, or say general knowledge where you have really hazardous materials involved upstream. They will also generally stand out in this assessment. So with that, that's a quick and short overview of our feedback or impression on using ProScale. Thanks very much.
Thank you. Thank you very much, Adrian. Very useful first approach. I'll now give the floor to Amanda Lundberg from IVL. She has a background in chemical engineering, and she's involved in the running of the ProScale consortium and in implementing some of the case studies. Amanda will share the results of a ProScale case study on plasticizers.
Yes, thank you, Genevieve. I hope you can see my slides. I will talk about the ProScale methodology for assessment of plasticizers, and that's a case study that we did last year. So the purpose of doing the study from our perspective was to illustrate the use of ProScale in a SSBD context. It was done by applying the ProScale methodology in one of the test cases that are carried out by the Joint Research Center, JRC, to test the SSBD framework. We compared the ProScale scores for 6 plasticizers over their life cycles. The plasticizers were included in gaskets used in pesto jars, and we used the functional unit of 1 kilogram of gasket. And the life cycle stretches from manufacture of precursors to end of use, including manufacture of precursors and plasticizers, compounding, gasketing, and use phase. And the modeling of the case study was done by the JRC, namely the building of the life cycle inventory and alignment of the datasets. And here you can see an illustration of how we modeled the plasticizer life cycles. So all the unit processes included are shown inside the system boundary, and with the chosen process categories, PROCs, as you can see beside some of the boxes. And transports are shown as the boxes with the letter T inside. So we did also corresponding modeling of the life cycles of the other included plasticizers, and they look very similar to what you can see here. So the building and alignment of the datasets took some time, and we needed to do some adjustments when using datasets from EcoInvent. But in the end, it resulted in that we have now default ProScale datasets for the plasticizers included in the study, as you can see in the right corner up here. We carried out a sensitivity analysis where the PROCs were varied for the production of one of the included plasticizers in the study, namely DEHA. The results from the sensitivity analysis show that the most conservative PROC choice gave the largest ProScale score, and the other way around, indicating that the model used in ProScale behaves like it is expected to. And here you can see an example of the results that we received in the study. And this example is for the life cycle of the plasticizer DEHP. And you can see the ProScale inhalative score per kilogram of a gasket per unit process on the x-axis. Let's see. It is illustrated how large the subparts of the ProScale scores are. So the typical results in the study as a whole were that the precursors were the significant contributors to the total scores. And that you can see here is that the transport in the butyraldehyde process dominates the total score of the whole life cycle. Yes, this study is one of the more rigorous ProScale implementations that we have done to this date. And we have expanded the default data repository, including the 6 plasticizers and their respective precursors. Also, some methodology refinement has been implemented. So that was the key takeaways from this study. We want to acknowledge that the work presented has been carried out under the context of the JRC analysis of different approaches to step 2 and 3 of the SSBD framework. And we did the ProScale assessment here was Therese Tjärneman, Amanda Lundberg, and Thomas Rudberg. So thank you for listening. I'll now invite Carla Caldeira from JRC to give her comments on this.
Okay, thank you, Amanda. Thank you, everyone. So just some comments regarding the testing of the ProScale in the SSBD framework. So as we said, we were testing different methods for step 2 and step 3. And so we contacted the team of Thomas, which we thank for the work that was done, to test the ProScale. So we are currently now comparing these tools and trying to understand what the data they need and all this. So we are still doing this, and we can see that the ProScale is a tool that is more simplified or easier to use. But on the other hand, we need to make sure that it's not losing any relevant information. So that's where we are at this moment trying to understand a bit what these different tools do and in the context of the SSBD framework development. But thank you to the team that developed the case study.
And thank you very much, Carla, for these comments and putting that in the general context. We have our last case study with Anna-Karin Hellström, who's a senior project manager on environment and sustainable chemistry at RISE, and she has a background in surface chemistry, and she's currently involved in Mistra SafeChem, Swedish project, where she's working on case studies that explore ProScale. So up to you, Anna-Karin.
Thank you. Thank you for inviting me here. I hope you can see my presentation. So yes, what we will present here is a case study within Mistra SafeChem with the title Citrated Crystal Nanocellulose from Post-Consumer Cotton Textile. And this work is a collaboration between Stockholm's University and RISE. It's published in the Journal of Materials Chemistry. And if you would like to read more about the whole case study, I recommend you to read the publication. Here we will focus a little bit more on how we evaluated and tested ProScale in this case study. So the motivation to this case study is that commercial available nanocrystals are produced from wood using sulfuric acid hydrolysis, but it gives a quite low yield, and it's also challenging to recycle the sulfuric acid because the sulfuric acid is dissolving the carbohydrates. So Stockholm's University, the team there, looked into new routes to extracting crystal nanocellulose from post-consumer cotton and using another acid, as in this case, citric acid hydrolysis. So what they do is that they take the cotton textile waste, they cut it in pieces, and then they hydrolyze it. And then there are some steps for cleanup and defibrillations. So the goal and scope was to evaluate the environmental sustainability and the toxicity potential with ProScale, identify hotspots of this novel route prepared from post-consumer textile by the citric acid hydrolysis. And then we would also like to compare this with extracting crystalline nanocellulose from post-consumer cotton by sulfuric acid hydrolysis. Now all these processes are at the low TRL, so we're still in the lab. So of course we have a lot of challenge with data here. So that's why we call this a kind of a screening lab LCA. And as Richard Arvidsson defined it during the CETAC presentation, like a lab scale LCA. And it's based on the framework by Piccino. And the function unit is 1 gram of crystalline nanocellulose. And we use the cutoff approach here for the post-consumer cotton. So just to give a little bit of the background, the result from the screening LCA showed that the environmental impact of the citrated crystalline nanocellulose is higher in 15 out of the 16 infant categories. But when we looked into the ProScale part, what we did here, you should not compare the results here, because the result of the ProScale is just normalized to the sulfuric acid crystalline nanocellulose. What we did here was to compare the process where we used citric acid for hydrolysis and when we used sulfuric acid as a hydrolysis. And what we can see is that for the ProScale part, that when we only focused on the chemicals, the toxicity potential of the chemicals, that the citric acid seems to have a little bit lower impact than when we use the sulfuric acid. But there are uncertainties around this, especially focusing on the citric acid production, what PROC to use, and uncertainties are also around the fungi Aspergillus that is used for the fermentation of the citric acid, because it has a respiratory sensitization, but we don't really know exactly how this is added and what form it's supplied in. And also for the CNC its own, we don't have any data about the toxicity here or the hazards. It is in water, 2% in water, and it's neutralized in the very end. But that's still something we hope to be able to get funding to consider in the next step. And using a worst case here, as described by Thomas, we kind of overrule all the other parts. So that's a data gap that I would like to highlight. If you look into the contribution analysis, the hydrolysis step, where we add the citric acid, is a dominant one in all the impact categories. And when we did the hotspot analysis with ProScale, here we compared the CNC prepared from sulfuric acid hydrolysis with the CNC prepared with the citric acid hydrolysis. The dominant of course process is the hydrolyzing step here, when we only are considering the chemicals. So key takeaway here, of course, we have high uncertainty because we have been using a lab scale LCA, but it can still assist in the early design phase and facilitate future scale up or giving input to that. But I would say it's more like knowledge enhancement, and ProScale can be used as a complementary tool, I think, or I believe, but it still have to be a little bit further developed, I would say, in alternatives assessment and safe and sustainable by design. ProScale is easy to use. You have a user-friendly interface, but I think that you need a transdisciplinary teams here to succeed, because you need to know about the process conditions. And also, as mentioned earlier, that the input data is also the key, the quality there, and the parameter selection can have a significant impact on the results. And with that said, I would like to thank you, the team at Stockholm's University, my colleagues here at RISE, and also VVT in Finland. Thank you.
Thank you very much, Anna-Karin, and thanks to all the presenters of these case studies. We have a few questions that we can take now. Anna-Karin, can you just cut your screen? Thank you. We have a few questions. No problem. And may I ask Adrian to join also right now, so we have the three presenters online. There's one question, I think that Amanda, is more that specifically directed to you. On the plasticizers example, did this include consumer exposure? And if so, how was the exposure modeled?
Yeah, and I will actually send that question to Thomas.
All right.
She's,
Joker.
No, that's an easy one. So I can pass it on to someone else, maybe. No. So, okay. Yeah, that's that was a fun thing to do. I guess unfortunately we didn't really have a chance to align in full detail what we did there with what JRC themselves did with other types of tools. So I can just describe how I did in this case. And we, you know, the gasket there is not in, well, so anyway, if you consider a gasket in a jar, it's at best not in direct contact with the food. So there is some a small layer of air in between. So basically I used what they call, I don't know, the question took me off guard a little bit, so I'm sorry for not being able to answer it right away. But if you think of various models that are used to calculate migration of additives from polymers, that's what I used here. So I calculated more or less the rate of migration of plasticizer out of this gasket and into the air layer in the jar, and then I assumed that the oil in the pesto would absorb this small amount very rapidly. So in effect, there is a transfer calculated from the gasket into the pesto, and then there was also the calculation example that a person will consume the pesto in a jar over, let's say, a number of days, which essentially gives you an oral intake of the substance. And I would say the determining factor here will be the release rate from the gasket of this particular additive. So the physical chemical interaction between the polymer and the additive will, if I may be a bit blunt here, say that this is the determining factor. And at least the results that came out were very different for the different additives that we looked at. So then, of course, I guess I wouldn't directly use the results as a basis for legislation on the matter, because there are certain issues, or when you look at these kind of substances, they are relatively low in their mobility, and they have actually quite differing numbers you can find on the let's say vapor pressure, for example, which is something you need, or the partitioning coefficient between polymer and air, and also polymer and octanol and water, which is or octanol air, which is what I used in this case. So it's a bit, okay. We don't need to go into the full detail, but essentially I looked at the migration rate of additives out of polymers and into, in this case, fat, which was, how can I say, approximated with octanol, so I could use an octanol air partitioning coefficient for the calculation.
Thank you, Thomas. Another question that relates to the first example from Adrian: is there any criteria to cut down the number of evolving raw material? For instance, in the first example, it looks like the first example did not look at PVC and acid precursors. So who wants to address that? Adrian and or
I don't see any relation to PVC in my example.
Yeah.
So maybe that's also the gaskets. Yeah. maybe a quick comment. Sorry, Thomas. Yes, even though our process looked rather simple with only these 3 precursors or raw materials involved, it's already quite an exercise to do that. Yeah, just as a comment. And if you look at something even more complex and what IVL did or Amanda did with the plasticizers, that must have been a lot of work. So it's not something you do in an afternoon or in 2 hours, just to manage expectations there. Thanks.
Thank you, Adrian. Any compliment there?
Yeah, I can just add and support or second that comment that, of course, when you have relatively recent method that we are talking about here, we have to start somewhere, and we are continuously, let's say, in the process of adding more unit process assessments to the data repository. But of course, we have a few things to do if we are going to catch up with EcoInvent, for example, that is there for the many of the other impact categories. That's clear. We don't hear you now, Genevieve.
Yeah, I know. Sorry. Okay, another question going back to the plasticizer case study. Were the production of transport means included in the ProScale inventory for the plasticizer study?
Yes.
Okay, simple answer. Another question that comes now, is there...
But then there is actually a kind of important point there, because it means that we also have a few, let's say, default data sets for transportation already at hand. And I will give a bit more of an update or indication of that, or at least talk about it a little bit later.
Okay, thank you. One last question. Did you compare the conclusions obtained via ProScale and the ones from the PEF with USTOX? That one should also look at direct exposure effects. Has there been any comparison made?
I could say for our use case, no, our case study, no, not yet, no.
We are working on such comparisons in the Mistra SafeChem project. I don't know if Anna-Karin is working on that, but there are many different things going on there, so something will come out. And I'm not sure how far. I mean, it was kind of up for discussion when we did the plasticizer case, but I don't know if how far that has gone. I have a case where we looked at the comparison in a previous work with, let's say, the current USTOX methods for indirect. I mean, we didn't exactly compare, we just looked at the case study where we applied both the USTOX 2.1 and ProScale and noticed that the hotspots coming out of the analysis were slightly different from each other. So that's an indication of a complementarity. But we haven't compared, let's say, the USTOX 3, which I think the question relates to ProScale. I mean, at least we haven't done it. And if anyone else has, I would be happy if they would come forward.
Okay, thank you, Thomas. I think there's a couple of questions left over from the previous session that you will address now, Thomas, in your next presentation. And you will give us a little bit more info about normalization factors, but also give us an overview of further expected ProScale developments. So please go ahead.
Yeah, okay, good. So let me know if you see my screen.
Yes, we do.
Okay, I will follow up on this study I mentioned where we did a complementary approach. It was a study on utility poles you know, these poles that are used for electric wiring in society and so on, where the old style poles are wood which are impregnated with creosote, and that's in theory banned, so there are many other options coming up. So we applied regular LCA, you could say, and then applied also ProScale in parallel, just to see if we would find anything, more meaningful information coming out. And of course, being a research project, it was in a way similar to what Anna-Karin mentioned. It was for additional learning that we did this. And of course, we all know that creosote is something we want to avoid, so we didn't expect anything else than seeing a lot of impact coming out with the creosote pole. But just for illustration, and of course this is not very surprising, if you compare the inhalation ProScale score, which is the green here, with the climate change impact calculated with LCA in the regular way, of course the impregnation of pole will be the dominating or the key aspect for the creosote case, whereas other processes will dominate when you look at climate change. And then we had also a comparison with some polymer-based poles, essentially made of PET, I think, but also covered with polyethylene or something. And I have to say that this is on a let's say it's based on the mass unit of pole. I think it's on one pole, so it's not relating to the life length of the pole necessarily. But anyway, it has a very similar, or the learning from this result is relatively similar. You can see that the PSPs, so the ProScale scores for inhalation and dermal, they have a certain pattern, and they are not exactly the same that comes out from the USTOX patterns, and also of course not the same as the climate change pattern. So some other aspects will be pointed out as hotspots if you apply ProScale compared to if you use other approaches. And I think that's one of the learning experiences here, that there are some additional learnings to be had from using ProScale in parallel with other methods. So let's just go further on. This was actually presented in a CTOC conference a couple of years ago, so we have at the website, or I can distribute it, the actual poster that was presented, and there is also an underlying report that outlines a little bit more the stuff. So that's in fact a case that we could have presented as well, but we've talked about it in a couple of other contexts, so I didn't want to exhaust you guys with this one. So instead I will mention the fact that one of the things that we identified at some point is that if we want to be able to use ProScale more in the broader sense in relation to other LCA impact assessment methods, it's important to have available some kind of global assessment that we can use in normalization or for normalization purposes to global impacts. So we compiled, let's say, a first version of that. So we compiled data for inhalation and dermal exposure using ProScale, and we based it on some of what we expected to be most important processes available around the globe. So we focused a little bit on petrochemistry and plastics processes, based on the fact that we know that there are some substances there that, or several maybe, that have a very high hazard classification, so they will contribute from that point of view, but also the processes are used in large quantities, so the quantity factor would definitely play a role there, which was essentially what happened as well. So yeah, here is a table that you don't need to bother too much about. It's actually the wrong one, in fact, because it should be, yeah, sorry. Let's see the coverage here. We studied about 60 globally important processes for this purpose. and with respect to the global production, or many cases the production capacity, and I show 19, and that's why it's the wrong table here, so don't bother about that. The total score is 1.2 10 up to the power of 14 ProScale points for inhalation, and for the dermal it just happens to be the same figure, but 1 order of magnitude lower in ProScale points. The key point here is that the processes that contribute the most, given this calculation, is the crude oil extraction, crude oil refining, and steam cracking. So basically 3 very, in terms of production capacity and volume, very big processes on a global scale. And as you see, if you add 43, 27, and 20, you come up with something like 90. So these 3 processes would at least contribute with 90% of the inhalative exposure-related toxicity impact among the processes we looked at. But of course, that's an important disclaimer that we looked at a finite number of processes, of course. So anyway, the takeaway message is here is that we may in fact use these numbers anyway as a first set of normalization scores, and that's where this table belongs to, because that's where I have compiled the global normalization scores as available from elsewhere, but I've added to the end of that table also the ProScale points that I just mentioned, inhalative exposure and dermal exposure, so they may in fact be used in the same way as you use other normalization scores on a global level, having in mind that it's a limited number of processes that are included, or that we included, and also things like metal mining and extraction and processing might still be interesting and important contributors. Now, so bear that in mind, but there is also the fact that the way you use normalization factors is actually that you put your product-specific results in the context of the normalization score. So if you are underestimating the global impact, you will in fact overestimate the contribution of your particular product. So in that sense, it will give the ProScale score a bit higher importance in your particular product for now. But I guess at some point, and of course in the process of adding more and more processes to the unit process library, we will also be able to create new versions of this normalization total. So having said that, I want to go into, and I would acknowledge my colleagues Marie Gottfridsson and Josefin Gunnarsson for assisting on the work on the normalization score. The normalization calculations were also presented in a conference in the conference called Eurotox, so there is also the further information on that available through our regular channels. Now I'd like to take the time to talk about the ongoing developments, some of them in the very near future ongoing, and some in a bit further down the line. Obviously, not everything can be done at once. We have 3 main themes that I think are worth mentioning here. Of course, we are, let's say, constantly working on all possible different aspects that need to be developed, but based on the availability of resources in terms of manpower and calendar time and whatnot, not everything can be done at once, of course. So the most interesting ones here, I think, is to, and also slightly then based on the comments we've received during the webinar here, I think finalizing the guidance we're working on how to derive preliminary H factors is an important one, and also, as has been mentioned several times, we are looking into ProScale E, as well as a module here for ecotoxicity. And I think also what some of our users have told us is that it has to be integrated in regular LCF software, otherwise, well, because that will improve the workability quite dramatically. So I will just mention a few things about that. The preliminary H factor work, you have seen this graphic already. You probably still cannot read what it says, but essentially we have created a very simple decision hierarchy. And as I mentioned before, if you can look at a substance that has not been classified and use appropriate computational tools, you may be able to define whether or not it will be, or let's say, has the properties that would potentially qualify it for being classified in the highest hazard class according to ProScale. So that's a work we are currently doing, mainly within the MISTRA SafeChem program. And of course, it requires some advanced computational methods. If you're working on risk assessment and toxicity of chemicals, you know that such tools are available to some extent. And for some, let's say, applicability domains, it's rather a matter of trying to choose the relevant ones. And for other hazard types or impact mechanisms, it's more a matter of not having methods available. So it's a work we are doing right now. What we want to achieve is, let's say, recommendations that we can put forward, how you can produce indicative classification suggestions, or like I said, predict properties that would more or less lead to a certain classification. Of course, we cannot set the rules for the actual classification. We can just indicate that the properties of this chemical would likely put it in this or that class. And as ProScale developers, where we would say that the hazard factors and also the scores coming out are so far indicative, it's good enough, I think. So it's a kind of a two-step procedure for us now. We are looking into the existing tools out there and see what can be already now suggested to be used in our context, of course, QSAR type tools. But what is also going on within MISTRA SafeChem is to look into the new developments in chemical property predictions. And at some point later on, we will, or hope to at least, and we are pretty sure that we will be able to make use of these new models as well, to have a better refinement of these tools. For now, we don't have any option like that built into the web tool. It might absolutely be a future option to have a more advanced way of integrating them. But that's where we are on that point. The ProScale E development, we are thinking of a similar philosophy as the current ProScale that we have at hand, where we combine H-prices with DNLs and OELs. Such a model may include an inbuilt emission model. Those of you who are familiar with isotoc-TRA know that isotoc-TRA starts with rather the occurrence of a chemical or in a mixture in a process, and then it predicts the exposure from there, whereas regular LCIA methods for toxicity has to get the emission from some other method that is, let's say, separate from the impact assessment. But in isotoc-TRA and other exposure-related prediction models, you can actually look at or see that the release rate, or if you call it emission, of a substance is kind of built into the model. So we think that's an interesting approach, because then you will simplify for the user at some point. And the whole idea with the PROC and these exposures coming out is an example of that. So whether that will be included also in the ProScale E or not is still up for discussion. And then there was a question in the chat, why not use DNL or OEL directly and, let's say, skip the H-prices? And the thinking there for the current ProScale is that there are many hazard phrases for human health impacts. And in the discussion, it was quite obvious that some let's say some impact types are considered much worse than others, even if they occur at a similar, let's say, concentration or exposure level or dose level. So it was very quickly understood that CMR, what is typically known as CMR substances, and they are currently in the highest hazard class, they were considered, you could say, worse than other impacts typically. So impacts possibly leading to lethal or with a high incidence of lethal outcome or other very severe effects are considered to be much worse, even if the effect can be identified at similar doses. So it's partly a matter of taking into account the potential consequence of causing an impact, you could say. It doesn't mean that necessarily this has to be the same for ProScale E. For one thing, there are much fewer hazard classes in ProScale E, so it might be, and this is my personal opinion, of course, that it might be, let's say, easier to agree on a way of doing it without necessarily applying the H phrases. But on the other hand, there are also new H phrases coming into the system now. So I think somehow there will be, both aspects will be combined. But that's so far my personal opinion. And maybe Peter wants to comment on that, because obviously Peter is also an expert in this area. But I will continue until you interrupt me, Peter. The third part here is about integration of ProScale in regular LCA software. Indeed, it's very important to get there at some point. But like I also mentioned before, we have some work to do before we catch up with, for example, EcoInvent. We have had discussions or are currently in discussions also with experts or the developers of the three, what we consider so far dominating LCA tools in the market. But of course, ProScale is not necessarily only related to LCA, even though that's where we have more of our current or where we came from in a way. So that's why this has made more sense. What we need, of course, to do is to discuss various things that are not only technically related, because if you interact with commercial software providers, there are some business-related aspects that come into the picture as well, of course. But of course, there is also a technical side to it, and it has to be defined exactly what you put where in the tool in order not to mess up things. And but I think, based on the discussions I've had so far, that it will not be that difficult, technically speaking, because essentially you have the hazard factor, which is more or less corresponding to a characterization factor, and then you have the dose estimate that comes from the other factors that you put into the unit processes of these tools, and then you have basically what you need in there. And then it's more a matter of making sure that everything that you put in is correct. So, but it's the work that we have to do, basically. And we have developed a small example in Gabi, just to make sure that we understand better how it would work technically. Yeah, that's where we are with that for now. So, a final point, how can you engage? But before we get there, maybe if, Peter, if you wanted to comment anything, if you're still in the meeting, and which I hope on the ProScale E part.
Yeah, probably. Thanks, Thomas, for all your explanations. So I think there's not so much to add, but we had some experience some years ago with ProScale E. So we used also a risk-based approach. So all the data are available. So there are a lot of parallel things, but the evaluation with ProScale E would be a little bit different, which is clear because it's ecotox and not human tox, and you need to consider something differently to the human tox part. We also compared it to some other ecotox assessment parts, and we think it's really a meaningful assessment that we can do there. And hopefully we can further push that forward and finally develop this ProScale method, because we learned that both is relevant and we should have these two methodologies in context to each other, which I think it's a good way forward. The normalization factor might be an issue, but that's another discussion how to come up with this. So when the methodology is finished, we will have test cases, we will have some comparison to other approaches, and I think we are fine. But thanks, Thomas, for your explanations.
Thank you, Peter. Are there any questions from the audience on some of the technical parts here, Genevieve or Amanda, that we should deal with before I go into the next?
No, not that I can see. I think we've addressed basically all the questions, and time is running, so if you could...
Okay, I will rush through this then. So now, of course, how can you guys engage further than today? Well, we have the ProScale website up and running. You can see the address here with most of the basic information. We haven't mentioned, well, we have mentioned the web tool. We haven't looked at it, but you can find your way through the menu to get there, and you can continue to the tool as here, but you can also contact us for further guidance here, how to log on and so on. We can definitely offer a certain test period and some basic support on how to use it. Of course, we have, like I have mentioned, such kind of a data repository. I think it's around 200 unit processes now. The list can be found also at the same place where you find the web tool link. And finally, for the method description in detail, you can find the guidance document, which is also available through the same site. And now I was going into the kind of a wrong. Here we are. Contact details. You can mail to me, obviously, but also to Amanda. We are the two main contact points for the ProScale Secretariat. That's IVL. And having said that, I can only say thank you for listening in. And again, just to remind us all that we are relying on some very generous sponsors in order to set up this seminar. And thank you very much. And over to you, Genevieve.
Okay, thank you very much, Thomas. That's a nice way to wrap up. I would like to complement your how to engage with also an invitation for anyone who wishes to join us in the development of ProScale E. There is a possibility to join the consortium in the next phases. So please contact Thomas or myself for that purpose. Thank you very much to all of you for joining us today, and many thanks, of course, to all the speakers for their contribution. Again, a recording of the webinar and the presentations will soon be available on the IVL website, and we will make sure that you get a link to this recording. So, well, don't hesitate to come back to us via IVL if you have still further questions, and again, don't hesitate to join the ProScale bandwagon for further developments. So I wish you all a very nice afternoon and a good weekend. Thank you again for taking the time. Bye-bye. Thank you.
Thank you very much. Bye-bye.
Thank you. Bye.